Alright, welcome back. So in this lesson we're going to be going through the ADS and how we're going to be implementing aiming down sight with our gun. I don't want to do it step by step too much, to kind of avoid going back and forward between the simple implementation and more complex system. So instead I'm going to show you how would I implement this thing in a more realistic environment, I would say, in more development style environment. And first things first, let's look at our animations that we have. So we have the animations for, for the rifle. We have rifle aim, we have rifle aim fire, we have rifle fire, and we have rifle idle. The rifle idle and rifle aim are essentially, you can switch between them, it doesn't really matter which one you're going to be utilizing. The rifle aim fire and rifle fire is the same thing. But we also have the animation that doesn't have an aiming counterpart, and that's the rifle run and roadie run. The run is essentially our walking animation, and we should be able to walk and see our walking animations while we're trying to aim down sight and while we're trying to shoot. So in this particular case, we're walking, we see our gun sway, we're shooting, and this thing is being added to our shooting animation, this extra sway. But we also want to do the same thing when we're trying to aim down sight. To do that, we're going to need to utilize something that's called animation blending, or specifically bone blending. And we're taking a specific part of the animation that we want to play, and we're putting that, which in this case is aiming down sight, we're taking the bones from that animation, and we're blending this thing as an overlay on top of the other animations that are playing the rest of our body animations. It's more of a technique that people use for third person or full body character. In this case, we technically only have arms, so we could kind of forego this. But depending on the type of the game we're trying to build, and especially if we're going to be building a multiplayer or something like that, we're going to have to make sure that the third-person character, or just the full-body character himself, will be able to play the correct animations and blend them while they're trying to walk and aim down sight at the same time, without creating a specific animation for it. And that's where the overlays are coming in. They're basically saying, like, if you are in a specific condition, keep on playing the animation, but for these specific bones that we specify, we want you to play a different one. And this could be a direct substitution, or it could be an addition to those things that are already playing. In this specific case, we're going to be playing the walking animation, and when we're going to be ADSing, we're going to be taking specific bones and telling them to play an aim down sight animation while we're still walking, as an overlay. So without further ado, let's go and actually define some of these things. First of all, we need the controls. I'm going to go to project settings. I'm going to make sure that inside input we have ADS or aim. I'm going to call it aim. Aiming is going to be right mouse button. There we go. Now let's go into our character blueprint. FPS player. Let's implement this function, or this event, aim. Now to control aiming, we're going to need a new bool. And we're using booleans for now. There's actually a better way to do that. In the more complex environments, I know that people are using gameplay tags, and we're going to deepen them if we're going to have some more time. But for now, aiming is all we need. So we're going to go here, and we're going to set aiming to true when we're pressing the button, and setting aiming to false when we are not pressing the button, when it's being released. Comment, aiming, or just ADSing specifically. Nice. So, right now I'm going to go into the animation blueprint. So let's skeleton mesh. Skeleton mesh, if you go to animation blueprint. And what I'm actually going to do is I'm going to create a new animation blueprint. And this animation blueprint is going to be specifically handling the animations for aiming down sight. And I'm going to call it skeleton. No, that's not what I'm going to call it. Where the hell is it? Hero. Animation blueprint. Everything here. Just so it's easier to find. And I'm going to call it overlay AV, animation blueprint. There we go. So how we're going to be using this thing? Well, we're going to go back into our character blueprint, animation blueprint. And as you can see, we're using these slots over here. And this is not what we're going to be using. First of all, we're going to be handling our locomotion, as we should. And instead of directly connecting this thing there, we're going to be caching this thing, saving the specific pose that is a result of our locomotion. And I'm going to call it loco pose. Now once we save this, once we calculate locomotion, we're going to be handling the overlay. And the way we're going to be handling overlaying is essentially we're going to go into, we're going to need a new state. Yeah, we're going to need a new state machine. Right, new state machine. Overlays. When we go inside, we essentially need to decide if we are aiming downside or not. So by default, we're not aiming downside. We're not really doing anything special. So I'm going to create a new state. I'm going to call it normal state. Connect it here. It's going to be a default one. And inside normal state, as you can see, I have the output animation pose. And this is something that's going to be coming out of the overlays over here. So inside the output pose, what I'm going to do, I'm going to take the cached new save cached pose. What am I doing? I need to use the loco pose that I've just saved inside here. There we go. Use cached loco pose. And I'm going to be utilizing the normal slot, because normal in this specific case is essentially a normal functionality. Like, nothing is special about it. It's not ADSing. We have basically two slots. One is normal, the other one is aiming. And if we're not doing anything special, by default, we're just going to be utilizing normal slot. So, normal. And the way it's going to play it out, when I'm actually going to connect everything, because right now it's just goes in here. I'm going to take this overlays, I'm going to cache this pose as well. Cache pose. I'm going to call it overlay pose. And the reason why I'm doing this stuff is because I want to utilize this thing. Well, first of all, loco pose, I kind of need it for the overlays. I need to save it and then do some modifications to side overlays. And with overlay pose, I could technically connect it over here. But in the future, again, if we do have some time, I want to play with some of the IKs and modify how the IKs are going to be working. So I'm going to be saving the overload pose and then doing some stuff with it, like IK modifications. and then outputting that stuff to the end. But for now, this is what we need, and we're also gonna be using this overlay pose, the one that we saved. We're gonna play the full body slots because I think we always need to play it, regardless of the situation. And we're gonna output this entire thing. So just to kind of reiterate what happened here. So inside locomotion, this is where everything is gonna start from this specific place. We're entering, we're deciding whether we're playing the idle, running, or sprinting animation. We're saving that pose, whichever it was, into a separate parameter. Then we go into the overlays. If we are not doing anything special, we're just playing the normal slots with normal animations there, outputting that stuff, saving, and then using the overlaid processed animation, applying the full body, and outputting that as a final thing. So we play this thing right now, it should be playing without much of a problem. It should do exactly the same thing we did before. And it does. It does play correctly. I think I can showcase this thing over here. It doesn't show it. But yeah, as you can see, it goes into normal state, it stays there. Inside locomotion, it doesn't show up sprinting, which kind of sucks. But yeah, it doesn't really require too much visualization. What else do I want to mention? That's pretty much it, but now for the actual reason why we need a separate overlay animation blueprint. It's because in here, if we are aiming down sight, I want to have a unique functionality added to it. So I'm gonna go here and create a separate new state. I'm gonna call it ADS. And the condition of switching to this ADS state is going to be a variable is aiming. There we go. So condition is aiming, so I'm gonna go here, connect this thing, connect it back, go inside go to, and say if you're aiming, then we are going to this state. If we are not, then we're going away. There we go. Probably should have given us an error because this doesn't actually do anything. And inside this state, we're going to be doing pretty much the same thing as we did before for now. And that's we're going to take our local pose, but instead of using the slot normal, we're going to be using the slot aiming. There we go. And that's going to be our output pose. So essentially, whichever is going to come out outside of the overlays is going to be either normal for shooting, for walking, or something that already has the ADS in it. And that technically should already be working. Like we do have the shooting with different types of nodes. Let's see. It's not done yet, but yeah, well, in order to make it work, we first need to get its aiming. Otherwise, it's not going to be set to true in any state or any situation. Animation graph. Get sprinting, get velocity. Let's just go in here. That's going to be pretty much a similar function. We're just going to need to implement get aiming player, class settings, interfaces, get sprinting, get aiming. Return is aiming. Compile. The player interface is aiming, and return is aiming. Compile, save, go in here. I'm just gonna copy this stuff inside this node, go back to event graph, inside the FPS action blueprint, animation blueprint, sorry. Paste over here, connect, still check if we're implementing the character interface, but instead of get sprinting, we're going to be calling get aiming. There we go. Remove this stuff, get aiming, and setting this thing like so. Collapsing into a node, call it get aiming. There we go. Now, technically should be playing different animations, like I'm not entirely sure. Yeah. It does play different animations, so it's already good. But yeah, not good enough. Okay, just give me a second. Okay, so that was already playing. I'm recording, right? Yep, I'm recording. So we are shooting, we're aiming down sight. It starts playing. So already not so bad. Not exactly what I had in mind. There are two things we need to fix. First of all, we need to be aiming down sight when we are not just shooting. We need to handle that. And we also need to make sure that we are changing our FOV, because just aiming down sight from this point of view doesn't really look good. So for now, let's handle the overlay. And as you can see, overlay action blueprint, it's exactly the same thing as the FPS action blueprint. The only difference that I'm going to make here is inside the animation graph. I'm going to create the input pose, which is going to be something that's going to be passed inside here, and this animation blueprint is going to be handling a different type of logic. That's the only reason why it's separated, just to make sure that we can modify them separately and store larger kind of chunks of data. Technically speaking, everything can be done inside one action blueprint, animation blueprint, but it's just going to grow into huge sizes for bigger projects. That's why certain things are usually being separated for, for organizational purposes, to make it easier to debug and change and modify and so on and so on. Especially if multiple people working on it. So the input pose is something that we can send from one animation blueprint to another. And we can also add different types of variables. It's like just an actual function, with the pose itself being one of the variables. So if you want to send like something like booleans or something else, just feel free. It's completely fine. And you can call this animation blueprint inside the FPS blueprint, which is exactly what we're going to do for this state, I believe. Yeah, in here. So we are inside overlays, we're going to ADSing, and we're going to be handling the ADSing logic from here. So what we need to do is to call linked animation graph. Yeah. Linked animation graph, and we're gonna need to specify which one. In this case, it's action AB. And another thing is that if you sometimes you will try to do this thing and you're setting specific animation blueprint and you don't see this in pose, don't worry, that's just because it did not update. Make sure the input pose is available inside the blueprint that you're trying to connect to. And just close everything, reopen, and you're going to be able to see this in pose again here. Well, if we just compile this thing right now, save, we go in here, compile, it doesn't show up for some reason. Interesting. Why they are not being showcased input parameter? We can't do that, can't we? There we go. Expose properties. That's what was missing. Go one. Yeah, we can basically just modify every single variable that's available in here. We don't need this stuff, I think. Yeah, we can just directly modify these things from here. So we just created a new variable, a dummy1 new variable 0, and we can just directly set this thing. So for example, we can pass it the information about sprinting. Is our character sprinting? We can just pass it directly in here. We don't need to do exactly the same thing as we did in the FPS action blueprint and start asking our character, are you currently sprinting? Now we can just pass those variables here and make this as our mastermind animation blueprint, while these are going to be handling the specific types of logic given to them. So we don't need this thing right now. Actually, we don't need any kind of type of variables, so let's hide that. Let's also remove this one because we're not going to need it. And yeah, so what's happening here is we're taking our pose that we have saved, we're running through and modifying this pose via the logic inside the overlay blueprint. Then we're activating every animation that has a slot aiming to it, and then we gonna try to output. So inside animation blueprint, it's basically we're gonna be storing this input pose. And actually, yeah, another reason to do that is, well, I'm actually going to showcase to you. You're going to see what's happening here. Because input pose, we can cache it, right? Not scale length, cache. I'm going to call it received pose. We can just directly send this received pose back. To it. And as you saw previously, we can do different types of manipulations with it. It's also really cool when you're trying to do the blend animations based on specific variable. It will allow you to take one animation, then check if the variable is true, and then take another animation instead. Which, yeah, let me just showcase it to you, what I mean. So let's say we want to play this animation, but if we are aiming, I want to play a different animation. Just as an example, not a practical thing. So there is a function called blend on bowl. Yeah, blend poses by bowl, which essentially allows you to do to take, let's say, the boolean of aiming, and if we're not aiming, we're going to be playing the basic animation, and let's say we're going to be activating the slot default slots, normal, false. And if we are aiming, we could be taking the slot defaults and connecting this thing to here, and we're going to be playing the aiming. But as you can see, I cannot just take this thing and connect it to both of those things. And in order to do that, well, I could just duplicate it and post it, but it's not efficient, right? That's why I need to cache my pose, to save it and then apply it in those situations. So I can take, well, not, yeah, let's take this pose. Saved, cached, lockup pose, and I can connect the lockup pose to these two situations. And then depending if I'm aiming or not, I'm going to be playing the correct one. So if I connect this thing in here, it should technically work. Yeah, that's still exactly the same thing. But that's a very simplified way of doing things, because you could be technically using different types of weapons, walking in a different way. Like, yeah, let's say you are trying to walk with a pistol, you're going to be using one type of animation. Then you're going to be walking with a assault rifle, it's a different type of animation, versus a sniper rifle versus a grenade launcher. Same thing about aiming. When you're going to be aiming down sight, you might have different types of parameters and different types of aiming animations that you're going to be utilizing. And if you're trying to do it this way, it can get really, really messy. So that's why we have different types of overlays, and we put them inside different types of action blueprints to make it a little bit easier to kind of organize and diversify. Another reason is because you cannot cache inside state machines. So if you're going to go here, for example, to ADS, and you want to cache this thing, you can't do that. These state machines do not allow you to do this thing. And it's actually a deliberate thing. And as far as I could tell, there was a response from one of the Epic developers. The reason why they chose not to do this is because there is a better way of handling those things. And this is exactly the one I'm going to be showcasing you guys now. And that's by utilizing different types of animation blueprints to separate those things that you want to essentially cache in most situations. So instead of caching inside the overlays into a specific states inside state machines, you can just create a separate animation blueprint and then a link connection to it and then handle what needs to be happening in here. That's the reason why we're using this thing. If that makes any sense. Like it's going to be easier to understand once you see what we're actually doing, and once you see the situations they can run into, and then you realize, like, okay, oh, that's the easier way to organize things instead of just trying to put this whole thing inside of one animation blueprint. So in here, what we want to do is we want to select which type of overlay we're going to be supplying. And this overlay is going to be depending on the type of the weapon that we're utilizing. So we're going to go into a new state machine. We're going to call it, choose weapon. Oh, Jesus, let me turn this music off. Put it back. So, state, yeah, we should don't need this time. Choose weapon is going to be handled not here, it's going to be handled in here, the overlays. Basically, this is not ADS, it's like aiming with the rifle, that's the way it should be called. ADSing, or specifically rifle overlay. that we're going to be handling. If we're going to have multiple weapons, we can just add different types of, well, overlays to it. But we're going to be selecting a, let's say, rocket launchers, shotguns, pistols, everything else. This could be handled in here, inside the FPS action blueprint, inside the overlays state machine. But inside the overlay action blueprint, for now, what I'm going to be handling, well, technically I could do, yeah, it could be an overlay rifle, not just an overlay action blueprint. Yeah, it just basically depends on how you want to organize this thing. For now, I'm just going to be handling this as an action blueprint. As an overlay, sorry. I'm starting to mumble too much. Anyway, yeah, so everything I'm going to need to do in here is I'm going to take the aiming, rifle aim, and I'm going to blend it with this pose, the input pose, right? So essentially what I'm going to be doing here, I'm going to be taking the received pose. Actually, I don't need to cache it right now. I can just paste it over here. And I'm going to show the blend. I'm going to call the function layered per bone. This will allow me to take two animations and blend them together on top of one another. And to do that, I need to specify exactly which bones are going to be layered onto one another and how I want them to transition, essentially. String groups I don't care about. I need to specify the exact bones I'm going to be utilizing, so it's going to be in here in layer blend per pose. Layer setup, I could specify multiple bones if I want to. For this thing, I don't need to. I'm going to just specify one. So I'm going to adding stuff. Now I need to have the exact bone name. I do believe it's key sensitive. So I'm going to go into Hero FPP, Skeleton Mesh. I'm going to try to figure out which bones do I need. Well, since it's just arms, it doesn't really matter that much. I don't think the rest of the stuff is not going to be animating. But in most situations, we're going to have a full body character, so we should be really picky about which bones we're going to be picking up for the animation. And in this particular case, I'm going to be using the spine_1 as my go-to. Copy selected bone names. Names? Just name. And I'm going to be pasting this thing over here. So B_spine1 is going to be my choice. And then blend option, how far they want this thing to blend. I'm going to just leave it at 0. And override. This is the type of the blending that you want to utilize. I'm going to use override because I want to completely override what's going to be happening there. And the result of this is essentially the pose that I'm going to be using. Here. Compile. If you look in here, this is our ADS pose that's going to be utilized whenever the ADS is going to be true. Compile, save. And if I'm not mistaken, we can actually showcase this thing from here. I haven't actually done that before, but yeah, there we go. Everything is working as intended. I'm just going to go into the preview editor and I'm clicking switch. And it's actually switching to the one that we utilized inside the overlay. And it's blending this pose correctly. Exactly as I wanted to. There we go. Yeah, we don't need this, we don't need caching. This thing is just going to be responsible for that. And the reason to have these things as a separate kind of thing is because, first of all, we're going to be utilizing different types of animations. Secondly, these settings could be different. Sometimes you need to utilize different types of bones depending on the type of the movement that you're trying to do. So it kind of makes sense to separate them and keep them inside different animation graphs. So yeah, just to reiterate, what are we doing? We're calculating our movement pose. Then we're taking that movement pose, we're running it through the overlays. By default, it's going to be running default overlay, which is going to just activate normal slot and pass it back. Or if we're trying to aim, in this particular case, we only have one weapon, so we're going to be checking one aiming. We're going to be connecting this thing through the overlay action blueprint, animation blueprint, sorry, and blending it with the aiming animation, and then outputting this whole thing. And once we saved it, we run a full body and output as a final animation. So here we go. That's our aim. Well, not entirely. Need to fix that. That's me trying to shoot while I'm trying to reload. That's not good. Okay, weapon blueprint. Check ammo. It's inside here, inside the FPS player where we're trying to reload. So we are out of gun ammo, stop animation montage, and then we're trying to play the animation montage again, but only if we are not reloading already. Get, not, and sure. There we go. It's kind of weird. Oh yeah, because we're just running the animation, we're not running the reloading thing. We're not triggering reload. From the reloading, can reload. No, that's not it. I'm just gonna make it into a separate function. It doesn't really matter that much. So yeah, can reload, checking this whole thing. We don't need to check it technically because we already know that we can reload. Then branch condition true, and then this thing. We can technically set this thing. Actually, the animation montage notes. Well, I should be taking this and making this a separate function, but there's such a limited functionality that I don't really think I should be doing that. Yeah. Just gonna do this. There we go. Yep, it does work. We can ADS. We can sprint. We can still ADS, which is not what should be happening, but we're gonna fix this thing later. Actually, we're gonna fix this thing right now. So let's say where's our sprinting? Sprinting is set to true. Yeah, it's sprinting. You do a lot of the stuff that needs to be disabled. And just to clarify, this is not the way to usually handle this stuff. It can get really cumbersome really quickly, requires a lot of booleans. If I were to refactor this thing, it will utilize gameplay tags or different enums for different states. But for now, let's just do it this way. And here I'm gonna set aiming to false. There we go. Now we're trying to ADS. I also need to make sure that we are not doing the ADSing when we are sprinting, or reloading it for that matter. So if we are in a branch, and we are saying that is reloading and is sprinting, either of them is true, then don't do anything. If it's a false, you can go into start aiming. Does that almost everything? Can't ADS, now I can. Yeah. So that's basically done with. Yeah, I can do some crazy shenanigans, but it doesn't matter at this point. It's just a part of polishing. What else? What else? I need to zoom in a little bit. Actually handle... yeah. I need to handle the ADSing properly, because right now it's just playing different animation, but we also need to change the way the camera is zoomed in. So for that specific case, I'm gonna have this thing over here, ADSing, and I'm gonna make sure that my camera is changing its FOV. Let's see, I'm gonna need two variables to be switching between them. So the default camera, default FOV, over tab float. Another one is ADS FOV, also the type float. For the default one, I'm going to be utilizing the 90 degrees, which is the default that we have. For the ADS FOV, I'm going to be setting this thing manually, so 55. And yeah, now I just need to make sure that they transition. The easiest way to do that is to kind of snap them. So when we are trying to aim down sight, let's just take our camera, get here, set field of view, and then you can feed it the exact value that you want. So in this case, we're going to be using ADS. And if we're no longer aiming, we're going to be changing our field of view to something different, to default. Which has its issues, because if we're trying to do that and we're also trying to change aiming in certain cases, it's not going to be updating properly. But just for the sake of example, as you can see, it's bang, bang. That's not really good. Obviously, suboptimal. Not what we're looking for. And we can actually make this thing move smoothly to update the camera. To do that, we're going to need to, well, first of all, probably call a new function, or specifically call a new event. I'm going to call this event custom event. It has to be an event. If it's not an event, we won't be able to utilize the timeline, which is basically a time-based function where we can control how smoothly our ADS is going to be happening. We don't want to be doing this thing linearly. We want to have some control over how it feels. So here we're going to be changing this to smooth ADS. There we go. And what smooth ADS is going to be doing is going to be taking the current state of our camera field of view And it's going to be updating that based on the values we're going to be providing. So we're going to be taking this, I'm going to get rid of that, and the value that we're going to feed inside the field of view is actually going to be a scalar from 0 to 1 to kind of scale between the default and ADS FOV. And to do that, based on the time, we're going to need a new thing called timeline. And timeline are ADS timeline. Timelines are really cool things because it allows us to feed certain variables and then put them into timeline and change them dynamically through, well, time. The easiest way to explain it is just to go inside here, and we could do this thing with multiple things, with colors, with event tracks, vectors, and specifically floats. For this example, I'm going to be only utilizing floats. So let's add our float track. And what it allows us to do is to essentially set the length. Think about it as an animation. We're playing animation, and all it does, it interpolates from one value to another. Right? So the length of our interpolation basically is going to be how long we want to ADS for. And I think 1 second, or 0.5 seconds, it's going to be enough. I think, yeah, let's just set it to 1 second. And we're going to start with value over here. We're going to set a new keyframe. That's going to be a value 0, at time 0. And over the course of this thing is going to be modified and go into here. The value is going to be 1, and the time is going to be 1 as well. But that's linear interpolation. That's exactly what we have normally. And but what this thing allows us to do is to modify this thing to make it a little bit more smoother if we really want to. We're going to ramp up really quickly, but then it's going to slow down by the end. Something like that. Let's see. External tracks, we don't need that. Track name. I'm going to call it ADS scalar. Oh, FOV scalar. There we go. So once we get outside of the ADSing, we can see that we get the value of ADS scalar. That's the flow that we just created. And if we activate this thing right now, you'll be able to see how this FOV scalar is going to be changing over time. So over the course of 1 second, let's say we start play from start, and we're going to play every single update. So every single time this thing is being called, smooth ADSing, we are going to print something and print this value and see what it actually gives us. Go here, ADSing. Oh yeah, we didn't call the event, that's why. So smooth ADS. Disable this stuff for now, we don't need it. That's ugly. Smooth ADS. As you can see, interpolates into 1 second, which is kind of long. Yeah. Probably want this thing to happen a little bit faster. So let's change this from 1 second to 0.5. Yeah, that should be better. There we go. So we're getting different values. What are we going to be doing with those values? Well, we're going to be interpolating between two different states. So we're going to be adding... Yeah, the way we're going to be adding this thing is I'm going to change this thing to have 2 inputs. One of them is going to be current FOV, and the other one is going to be target FOV. And they're not booleans, they are floats. interpolate, I think it's lerp. There we go. Lerp from one to another. Lerp is linear interpolation. So we're changing one value into another, and the alpha is responsible for basically how far we're coming from one to another. So it's basically a percentage. Think about it this way. So let's say we have a value of 1 is going to be A, and a value of 100 is going to be 100. And the alpha is responsible for telling us, well, at which point between 1 and 100 we should be staying. And it's the usual value of 1. So we're going to be attaching the scale in here and basically outputting this value to be setting our field of view. So in this way, we're just going to be moving from one to another at this specific speed and setting this thing every single update. So that's basically it. Direction, I don't really need this direction. Can't remove it, I guess. Yeah, just smooth ADSing. It's going to be a part of it. And for this specific case, our current FOV is going to be default FOV, and target is going to be ADS, and vice versa. Just to showcase this, as you can see, it smoothly transitions. Probably need to make it faster at the end. Yeah, this part is a bit annoying. There we go. There we go. And we remove, it goes back. The only problem is that we should here right now, I'm trying to reload. It doesn't actually do the proper job because we're not disabling the aiming. I mean, we're disabling the aiming, but we're not calling this thing out to work correctly. So, actually, smooth ADS is not the correct name for this one. I think I'm going to call it update camera FOV. That's a better description for it. And I think I'm gonna make this thing into an actual function. Yeah, because this is gonna be annoying to be placing around all the time. Or a macro. I could make this thing into a macro. Yeah, I guess so. Force reloading. Maybe checking aiming. Whether or not we're going to be handling it in a different way. Yeah, let's make it a macro. Doesn't really matter at this point. I'm going to call this macro handle ADS. I'm not usually using macros for this purpose. That's why I'm thinking about, like, is it optimal? Technically speaking, yes. Like, we don't need to call the function because we're not going to be doing anything with that function. So inside of here, we're going to be checking what value is being passed to us. In this case, it's going to be a boolean, and that's going to be is aiming. I'm going to be setting aiming here. And depending on what it is, if we do it this way, I'm going to select. So if aiming is true, then I want my current FOV to be true. Just trying to make it more fancy than it probably should be, but bear with me. So if aiming is true, then my current FOV needs to be default. Actually, not even default, it should be current FOV. Yeah, just because we could be at the different stages. Let's see. Camera. Field of view. Actually, get field of view. There we go. No, never mind. The reason why it's not going to be working because we don't want to interpolate for 1 second or half a second between, let's say, like if the value of ADSing default one is, let's say, over here in this spot, and so this is the default and this is the ADS. We could be in the process of transitioning, then stopping something and going back. We don't want it to take the same amount of time it takes from going from A to B. We want it to take the remaining amount of time. So yeah. Okay, yeah. Never mind. That's let's just keep it that way. I don't think it's going to be a problem. So current FOV is default FOV. If we are aiming, just starting to aim, default FOV is current. If we're not aiming, our ADS is current, and it's going to be vice versa. It's going to be opposite essentially. For this one, the target FOV, if aiming is true, it's going to be ADS, and default is going to be false. There we go. And we're going to start updating the camera FOV from here on. You can also make an output here. Now if I go back, handle ADS, aiming is true, and here it's also going to be handle ADS, but aiming is going to be false. There we go. Here we're going to be setting handle ADS. To false. That's it, I guess. Should also stop ADS when we're sprinting. Sprinting true. Yeah, that's exactly what we're doing this thing. When we're trying to reload, reloading, sprinting, okay, reloading false. Reloading is true. And also should be handling ADS. It's false. I'm gonna do one more thing. That's to add if are we aiming or not to the update camera FOV. And the reason for that The reason for that is because I don't want to use the same curve, I want it to be in reverse state. So here and back, here and back, here and back. There we go. Now I don't really pick that. Oh, it's big. Yeah, never mind. It should not be doing that. Where did I mess up? There we go. So, how should I explain it? So what this thing allows us to do, essentially, when we are hitting play, and yeah, by the way, I forgot something, loop. There we go. No, I did not forget looping. I should not have used looping. Turn back to the event graph. Set play from start. And now looping should be working. No. Yeah, let me just explain this thing and then I'm gonna fix this later. So the way it works is, where the hell is it? There we go. This is kind of a persistent thing, to explain it. But essentially, once we start playing this, it goes from start to finish, and it stays there. That's what you're trying to play. So it's really good when you're trying to ADS and try to un-ADS afterwards, because if you do something like this, let's say you are aiming, are we already aiming? Yes, then try to reverse play it. Are we not aiming? No, then try to play it now. So we're going to do this thing right now. It's going to be doing ADS and back, ADS and back, ADS and back, ADS and back. So that one is essentially playing it from 0 to 100 and then from 100 to 0. So that's super nice, because if we get kind of interrupted at certain point during the ADS and we want to reverse it back, so to say, it will work just fine. If we want to start it from the start all the way and every single time, then we need to take the play from start and utilize this variable. Or we can stop it if we really want to, but not for ADS and not for this particular case. Same thing works with reverse from end. It basically means you're going to be setting, let's say you stopped at halfway through, but you're not happy about it. You want to continue reversing, but you want to continue from the very end. You can do it by doing this. It's like the opposite of play from start. So you're either starting from the beginning or you're starting from the end. You can do the play thing. And once it's finished, it does something. It updates. So the problem that we're having here is that it needs to be basically a bit more sophisticated than this right now, and I don't really remember how to do it properly. So I'm just gonna experiment a little bit. So right now, when we are ADSing and we are basically taking the current AFOV It's always going to be importing a specific value from here. So it's fine. Let me just take a moment to think about it. I'm going to be right back.